Hello and welcome back. Remember, the objective of this Crack Me is to patch the EAX value with the correct value. So let's get started. Let us open the Crack Me with x64dbg and make sure your options are set as follows. Option preferences, uncheck system breakpoint, uncheck TLS callbacks, and make sure these exceptions are ignored. So we are now at the entry point, and let us now trace over it, animate over. Instead of pressing F8, recall that we can do this. So it will auto F8 for you all the way until the program is running. And you can see the status, it is running. And now the last call that was made is this call. This is a call which caused it to run. So now we shall put a breakpoint here so that we can step into it in the next restart. Double click to set the breakpoint and let's restart. Now let's run to our breakpoint by clicking run. And now we are at the breakpoint. Let us step into it by pressing F7. And we want to know what causes the program to be unregistered. So we press F8 to step through and analyze the code. And when we come here, we see there's a series of moves to EAX. And here there's a comparison and a test. And here you will see there is a string registered, and there is also an unregistered string. And the jump here jumps over the good string and goes to the bad string. So this is what causes it to be unregistered. So let us F8 to step over this and confirm it. F8, and now we can press F9 or click on this, and you can see it is showing unregistered. So this unregistered obviously came from here because of this test, and this test depended on the value in EAX. So let's put a new breakpoint over here and restart the program. Run to our first breakpoint, which is this. Run to our second breakpoint, which is this test. So it is this test here which tests whether the EAX value is 0. In the past, we have seen that test EAX, EAX means is EAX value 0. So it is asking whether EAX is 0. So if EAX is 0, it will set 0 flag to true. In this case, EAX is indeed 0, therefore the 0 flag is set to 1. So if we press F8 now, jump equal to 1. That means this jump will take place if the 0 flag is 1. So in this case, 0 flag is 1. So it will jump. So over here, we can write a comment, and this is how you write comments. You can double click here in this column and put a comment: should not jump. So this is to let you know that you should not jump over here, because if you jump, it will land in the bad message. If you don't jump, it will go on to show the good message, which is called registered. So over here, we should not jump. So now the question remains, we can go up one step further. What sets the EAX value? So we can see the EAX value is being set over here. This is the one which sets the EAX value. So we can go up here and put a breakpoint, but we are not sure whether or not this instruction will be reached, because there is a jump here which seems to jump over this instruction. So the correct breakpoint should be set over here. to see whether or not or why it jumps over this instruction. This is a good instruction because it sets the EX to 2. If the EX is 0, then it will cause this to jump. But if the EX is 2, this will not jump because it is not equal to 0. Therefore, this is a good instruction. We want this. But we have to analyze why this is jumping over it. So we should put a breakpoint here. And we can remove this breakpoint and restart the program. Now we run to the first breakpoint. I think we can remove the first breakpoint. Now we run to our second breakpoint, which is here. So as you can see, it is jumping over this good instruction, and this one is should not jump. So we can put another command here, just like how we did earlier. Earlier we put a command here, should not jump. This one also should not jump. So we can write a command, double click, should not jump. Click OK. So here we should not jump. Just like here we should not jump. So what determines whether this will jump or not? Again, the test is jump equal. That means it will jump if the zero flag is equal to 1, which is, in this case, the zero flag is equal to 1. Because of this test here, the test will check whether EX is equal to 1, just like here. So what sets the EX whether to be 1 or not? Depends on the preceding code. So you can see here it moves 5 to EX, moves 5 to ECX, and deducts or minus ECX from EX and store the result in EAX. This instruction sub EX, ECX means take the value in EAX minus from the value in EX and store a result in EAX. So if ECX has got the value 5, you will take 5 minus 5 from here, which is 0, and then store 0 back in EAX. So this is what is causing EAX to become 0, and that is bad, because if EAX is 0, then this will jump. So where do you think we should patch? Yes, we can patch here. We must ensure that this instruction either does not happen, or we must set the value of EX to anything other than 0. So let me show you. One way is to set it to not NOP, no operation, which is one option. And the second option is to move a value 1 into EX. So let's try the second option. Double click and make sure you check on size, keep size, and this is also checked. Let's move EAX one, and you can see the instruction is bigger by 3 bytes. That means we can't assemble this, because if we assemble this, if we use up the 2 bytes here and then use up another byte from here, and that will destroy this instruction, which we can't do. We need this test, so we don't want to destroy this instruction. So what do? We can move 1 to the AL. Instead of EX, we move it to AL. And we have seen in the earlier lesson that AL is referring to the 2 bytes down here. So this is AL. So if we move 1 to AL, EX will become 0, 0, 0, 0, 0, 0, 0, 1, which is still 1. So that is fine, we can do this, and you can see the instruction is same size, so this is okay. So we can click OK now. And click close this, and now we have assembled move 1 to AL. So that is okay. So let's go ahead and patch it. File, patch file, click patch, give it a new name, crackme7-patch, click save, click OK, close this, and let's load the file, load the patch file, open, and run it. and you can see successful. The status now reads registered. So this is a good lesson on the how to trace EAX and how to patch it with the correct value. Many programs out there depend on the result of EAX in order to determine whether or not the software is registered, and EAX is usually set by a function call which returns, and also set by other comparison or operations which usually stores the result of the operation or comparison inside EAX. So by patching EAX, you can actually cause a software to become registered. So thank you for watching. I'll see you in the next lesson.